mathematicians. Mr. Serpico checking in here for day 2 of 14.3 Prisms and Pyramids. I have a PowerPoint slideshow I'm going to share with you. Some explanations on some drawings and some figures. We're going to look at some 2D figures that could become 3D figures. You think about nets. You think about a solid piece of paper and how you could create shapes in it. And if you were able to fold it up in such a way, you could turn it into a prism of some sort or a pyramid of some sort. I know kids in 5th grade in the past have made those dream catchers or origami. So to activate your prior knowledge, think about those. Think about paper formations, nets. Think of another good example would be a shoebox. If you ever took a shoebox and you broke it down where all the seams are, it would form almost like a letter T. And if you just refolded that shoebox back together into one solid shape, you could form that rectangular prism again. So bear with me as I take you through a slideshow of prisms and pyramids. I'll explain some of the drawings, and then I have another short video at the end, and then some practice for you in the form of Khan Academy. So the solid figures from nets. A net is a plain figure that can be folded to make a solid figure. More than one net can form the same solid figure. So in this first example, there's a cube cut along some edges, and you can see when you were to unfold that along the edges, it could form a shape such as the one I just described, this T right here. There's lots of ways, several ways that you can unfold the cube to make a net that would refold and recollapse into that cube shape. So let me scroll down a little bit here. Sorry. All right. Here's 2 more nets, as I was saying, that could form a cube. So as you can see, this one is 1, 2, 3, 4 squares this way, a square here and a square here. And if you fold these over, they'll kind of loop around, wrap around, and then fold these sides up. You'll have a cube that way. And this one almost looks like a sideways capital letter M. And if you were to fold this one up, you could also make that same exact cube shape with the same number of vertices and edges. And then this one could be an activity where you look at the shapes, the net, so to speak, and you figure out what's missing. And you could see I added this extra block on here. So these are some things you can experiment with home if you want to send a picture to your teacher of a net that you made using using squares. One cool way to do it would be to just make a whole bunch of squares like this, okay? Just make them, literally make squares that are the same, okay? Yes. Okay, so just make squares that are the same size, and then play with ways that you could attach them together to fold up and make into a cube. And remember, you wouldn't want any overlaps. So that's something that you could do at home. Here's another one. Can you guys figure out what this one was? We talked about it a little bit in yesterday's lesson. So it's all of the bases and faces are in the shapes of triangles, right? So if you were to flap up this end and then this end and then this end, they would come to this apex here where this yellow dot is, and they would form a triangular pyramid. Okay, you probably guessed that already. Take a look at this drawing. So you're looking at, on the right side, the 3D version of what it would look like if you folded it together, and on the left side, how it would appear as a net. And then I tried to label the shapes and the faces so that you could see what they would look like from one to the other. So you can see this is the FG right here, FG. Looking at if you were to fold up the flaps on the sides of this net, you would create this cube. All right, so transforming a net into a 3D shape. Let's take a look at this one here. Again, exploring different prisms. You've got a triangular prism, you've got a rectangular prism, a pentagonal prism, pentagonal prism, if you will, hexagonal prism. So you're naming the prism after the base. So a pentagon, a hexagon, a rectangle, and then a triangle right here. The number of sides for each base, the number of rectangular faces connecting the bases. So in the triangular prism, there's 1, 2, 3 rectangles. Looking at these faces and bases. In the rectangular prism, number of sides at each base, so there's 4 sides at the bases. 1, 2, 3, 4. 1, 2, 3, 4. And then the number of rectangular faces connecting the bases, there are 4. So face, 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 face. 4 faces connecting at the bases. Pentagonal, you've got the 5 sides hitting the bases, and then the number of rectangular faces connecting the bases is 5 again. Sorry about that. 1, 2, 3, 4, 5. 5 rectangles all operating around this base or this face of a pentagon. Same thing with a hexagonal prism. You've got your base of a hexagon, and then you've got the rectangles, 6 of them going around to connect those 2 faces. Now we're looking at some pyramids. You got your apex up here, you've got your bases down here. Remember, a pyramid is named after its base. So you've got a triangular pyramid, you've got a square pyramid, pentagonal pyramid, hexagonal pyramid. Number of sides at the base, so you've got 3 in the triangular, 4 in the square, 4 sides, 5 sides of the pentagon, 6 sides of a hexagon, of course. So these sides make additional faces. So the number of sides of base matches the number of faces because they go up to that 1 apex. So if it has a side, that's a face, and it goes to the apex. So for additional practice now, you're going to try your workbook page 196. Again, if you're feeling the desire to check in and share that completed sheet with your teacher, feel free to do that. There's a Khan Academy link right here. I'm going to add it to the folder as well, where you could follow this a different version of this lesson again in a smartboard type format. I was experimenting with the PowerPoint format for this, just taking it right out of the textbook. But you can watch Sal Khan do one of his videos, and then immediately after his video is a practice, which would also give your teacher an indication of how you're dealing with this. Okay, thank you, mathematicians. Hope you have a great day, and we'll see you guys again soon.